Going through the solution for question number 6 on your project, which is meant to be a study guide for test 2. Now this particular question is about interpreting a Tukey table for a one-way ANOVA. So let's go through the question first. It says here, a researcher wants to determine the effect that smoking has on resting heart rate. They randomly select 7 individuals from 3 categories: non-smoker, light smoker. So light smokers are those that smoke fewer than 10 cigarettes per day; heavy smoker, those who smoke 10 or more cigarettes per day. Given the following 2 key results of the data, answer the questions given below. So over here it says, is there sufficient evidence to support the belief that at least one of the means is different from the others at the alpha equal to 0.05 level of significance? That's a 5% significance level. And they've asked us to use the notation mu sub ns, ns for non-smokers, mu sub ls for light smokers, and mu sub hs for heavy smokers. And the first question says, state the null and alternative hypothesis. Now this is a Tukey test, therefore we will have to state our hypothesis for a Tukey test. Before that, we learned how to write the hypothesis statement for the ANOVA test, where the null hypothesis stated that, so the way we wrote our hypothesis statement for a general ANOVA test was mu sub 1 equals mu sub 2 equals mu sub 3. So in this case, if we were to apply this for this particular example for smokers, it would be mu sub ns equals mu sub ls equal to mu sub hs. And for the alternative hypothesis, we would state that not all means are the same. It's incorrect to state the alternative hypothesis as mu sub 1 not equal to mu sub 2 not equal to mu sub 3, or mu sub ns not equal to mu sub ls not equal to mu sub hs, because the fallacy in there is that some of the means may be equal to each other, but there may be some means that are not the same. So there's a possibility that some of the means are same, but not all means are the same. Now this is the way we state our hypothesis when it comes to ANOVA testing. However, this is a Tukey test, therefore it's going to be stated a little bit differently, because in a Tukey test we compare 2 means at a time. We compare 2 categories at a time. So let's look at the categories that we will be comparing in the Tukey test. So let's focus on the table here. It says non-smokers. This is a multiple comparison table. So non-smokers subtracted from light smokers, and then non-smokers subtracted from heavy smokers. So the first table here is comparing light smokers with non-smokers and heavy smokers with non-smokers, right? So I'm going to write that down on the side. We have non-smokers, we have light smokers, and we have heavy smokers, 3 category of smokers. And then in this first table we are comparing non-smokers and light smokers, and then we are comparing non-smokers and heavy smokers. All right, so that's being done over here in the first table. In the second table, it's comparing light smokers with heavy smokers. So light smokers and heavy smokers. So there are 3 sets of comparison. The first one is non-smokers and light smokers, then it's non-smokers and heavy smokers, and then finally we have light smokers and heavy smokers. That's the three sets of comparisons that we are making. So for a Tukey test, the way we are going to state our hypothesis is going to look like this. There's going to be three sets of hypothesis statements. First one is for NS and LS. So we are going to write it as mu sub NS is equal to mu sub LS. The null hypothesis will always state that there are no differences between the means, they are all the same. Alternate hypothesis will state, now because we are comparing two means at a time, we will write it as mu sub NS is not equal to mu sub LS. The mean for non-smokers is not equal to the mean for light smokers. So that's the first set. Then the second one is comparing NS and HS. So how do we write that? Same process, but this time the subscripts are going to be different. So mu sub NS is equal to mu sub LS for the null hypothesis statement, and for the alternate hypothesis statement it's going to be NS is not equal to mu sub LS. And then finally it's going to be for light smokers and heavy smokers, this one here, it's going to be null hypothesis colon mu sub LS equals mu sub HS, and alternate hypothesis will say mu sub LS is not equal to mu sub HS. All right, so for a Tukey test, this is how you're going to state your null and alternative hypothesis, and there are going to be multiple sets of statements. All right. Now the next part of the question says, based on the p-value, choose the appropriate decision from the choices below. So we have these four options given to us. We have to choose one of them, but let's go up to the table and just look at the values to determine whether the decision should be a reject or a do not reject null hypothesis. So I'm going to go up here and look at the values on the table. All right, so let's look at the non-smokers and light smokers first. The lower end of the confidence interval has a positive value, and the upper end also has a positive value. So this is a confidence interval at the 95% level as given here, and for the confidence interval between light smokers and non-smokers, so LS minus NS has a lower end of 3.9 heart rate, and the upper end was 21.79. So both these values are positive, and when both endpoints of the interval have the same sign, that means it does not contain a difference of 0. Therefore, that tells us there is a difference between two means. Also, the p-value is 0.0047, which is pretty low compared to an alpha value of 0.5. So that tells us to reject the null hypothesis. The null hypothesis stated that there is no difference between the mean, but based on the value of p as well as the lower and upper ends of the confidence interval, we can conclude that there's no difference in the means between non-smokers and light smokers. As for non-smokers and heavy smokers, it's the same thing. We have two positive values at the lower end and the upper end respectively. That tells us that there's no difference between the means because it does not contain a 0 as a difference within that interval. And look at the p-value, it's a very, very low value, less than 0.0001, which is definitely less than alpha for sure. So the conclusion is there is a difference in the means between non-smokers and light smokers, non-smokers and heavy smokers. As far as the table here, which captures the confidence interval between light smokers and heavy smokers. So heavy smokers minus light smokers, we see that the lower end has a negative value, the upper end has a positive value. So this interval contains a difference of 0. That means there's no difference between the light smoker heart rate and the heavy smoker resting heart rate, correct? So let's write that down. This one is no difference between LS and HS. So if there's no difference, then we do not reject the null hypothesis. If there is a difference, then we reject the null hypothesis. And because some of the means are different, the decision is definitely going to be reject the null hypothesis, right? So based on that, now that we know that the null hypothesis should be rejected, the overall null hypothesis for the ANOVA, let's see which one we are going to choose. So the two options that we will have to consider, the ones with reject in it, correct? Reject null hypothesis. So that's number 1 and number 3. Let me circle these here. All right, so this one here and this one here. It's a tie between the two. So let's see which one is the correct answer. I'm going to read through it completely. It says, reject null hypothesis. There's sufficient evidence to support the hypothesis that all of the mean resting heart rates are different. Now this one says all of the mean resting heart rates are different. We saw up here that not all are different. Light smokers and heavy smokers have the same heart rate. So that tells us that number 1 is not the correct choice. We can eliminate number 1 as well. So we are now left with number 3, which is reject null hypothesis. Let's go through it. It says there is sufficient evidence to support the hypothesis that at least one of the mean resting heart rates is different, which is correct. We have actually 2 heart rates that are different between light smokers and non-smokers and heavy smokers and non-smokers. So our choice should be number 3, right? Now the next question says, state the appropriate conclusion from the choices below. The first one says the mean resting heart rate of light smokers is different from the mean resting heart rate of non-smokers. This is true, correct? So if we go up here, we saw that there is a difference between the heart rates of light smokers and non-smokers. That's why we rejected the null hypothesis here. Both the ends for this confidence interval were positive. It did not contain a difference of 0. So that told us that there is a difference between them. Correct? So this one is right choice. But let's look at the other ones. Number 2 states the mean resting heart rate of light smokers is different from the mean resting heart rate of heavy smokers, which is not true. If we go back to the table, we will see that light smokers and heavy smokers here, they had a negative sign for the lower end, a positive sign for the upper end. Therefore, it contained a difference of 0, which tells us that there's no difference between the means. Also, if you look at the p-value, it's 0.1133, which is pretty high. 0.1133 is definitely much higher than the alpha value of 0.05. Therefore, we should not reject the null hypothesis for this comparison. So the right answer is C. The null hypothesis is not rejected, is incorrect. We did reject the null hypothesis. And the last one said all the means are significantly different, which is not true either. And finally, part D asks, is there a difference in the mean resting heart rate of light smokers from the mean resting heart rate of heavy smokers? Justify your answer using the data on the table. So again, let's go back to our table. We are looking at this section of the table, light smokers and heavy smokers. Again, we saw that this interval contains a difference of 0. So that's one reason why there's no difference between the two categories, and also the p-value. So there are 2 reasons why we should say there's no difference between the heart rates of heavy smokers and light smokers. So the way you're going to write the answer is, so I have written out the answer here. There's no difference between the heart rates of light smokers and heavy smokers. Why? Because number one, the p-value of 0.1133 is greater than the alpha value of 0.05, and number two, the confidence interval contains a difference of 0. That means the lower end and the upper end had opposite signs. Lower end negative, upper end positive. Therefore, the conclusion is that there's no difference between light and heavy smokers. All right?